Hello everyone, my name is Sir Jigs. Welcome to Jiggy Math. So I'm here once again for another lesson video. So after Pascal's triangle, that is the first video in the series of binomial expansion. The next is binomial theorem. So what is binomial theorem? But let's have a review first. Okay, so from the video of the Pascal's triangle, so this is what we discussed last time. Alright, so the coefficients in the binomial expansion, for example, a plus b to the power of 3, the coefficients are 1, 3, 3, 1. You can find that as well when you draw the Pascal's triangle. And we're talking about the third row, the numbers in the third row. Likewise, if you have a plus b to the power of 4, the coefficients, you can get these coefficients from the fourth row, from the fifth row of the Pascal's triangle, 1, 4, 6, 4, 1. Okay? Now, aside from drawing the Pascal's triangle, you can also obtain the coefficients in the binomial expansion by getting the combination. For example, 1 is combination of 4 taken 0, and then 4 is combination of 4 taken 1, and it follows that 6 will be combination of 4 taken 2, and then 4 is combination of 4 taken 3, and then 1 is combination of 4 taken 4. So those are some of the things that we need to remember when it comes to the coefficients. All right. And another thing is, if the index is 4, then we will come up with n plus 1 or 4 plus 1 number of terms. So in this case, we have 5 coefficients or 5 terms. All right. Now, if you look at this expansion, you can also write this expansion in this manner. Okay, if you look at this, 1a to the power of 4 can also be written as 1a to the power of 4 b to the power of 0, because b to the 0th exponent is equal to 1. Okay, likewise, the last term, which is 1b to the power of 4, can be written as 1a to the power of 0, b to the power of 4. So if you look at the powers of the a, or the powers of the first term in the binomial, a to the power of 4, a cubed, a squared, a to the power of 1, and a to the power of 0. What do you notice, or what can you say about the powers of a? All right. The powers of a are descending starting from 4. Okay, so it is descending. It is decreasing starting from 4. Why 4? Because 4 is our index. Okay, so a4, a cube, a square, a1, a to the power of 0, which actually corresponds to the 5 terms that we need to have. Okay, so what about the powers of b, or the powers of the second term in the binomial? So if we look at this, b to the power of 0, b1, b squared, b cubed, and b to the power of 4. So this time, the powers of b are ascending. Okay, that is from 0 to 4. Okay, and then again, they correspond to the 5 terms that we are expecting. So uh, we discussed how to obtain the coefficients from the last video on Pascal's triangle. Now we're looking at the literal coefficients, the variables, and the corresponding powers. Okay, so um, quick tips. Okay, another thing that we can actually observe from the coefficients is this. First term, the coefficient is always 1. The second term is always 1. So you will have this 4, combination of 4 taken 0 is always equal to 1, and combination of 4 taken 4 is always equal to 1. Alright, so that's one quick or shortcut. You don't need to use scientific calculator for this. Combination of n taken 0 is always 1. Combination of n taken n is always equal to 1. Now, another thing that we need to look at is the combination of n taken r is equal to combination of n taken n minus r. Okay, for example, combination of 7 taken 5 is equal to combination of 7 taken 2 because 2 is obtained from 7 minus 5. If we go back to our example, if we look at combination of 4 taken 1 and then combination of 4 taken 3, they are the same because 3 is 4 minus 1, right? Okay, so take note of that. So which means um, once you already know the value of combination of 4 taken 1, so you can already know the value of combination of 4 taken 3 because they are just the same. Okay? Yeah, sometimes doing things like this will shorten, our time in calculating, in computing, and in showing our working. Okay, and of course, you have to be good in the laws of indices. You have to be good in the laws of exponents. So make sure that you master those laws. All right, so let's go now to the binomial theorem itself. And we can use this in the expansion of a plus b to the power of n. And that will be equal to a to the power of n because combination of n taken 0 is just 1. And you're supposed to have b to the power of 0 here, but that is just equal to 1. So that is just a to the power of n. Alright, and then the coefficients, as you can see, the value of r is increasing, okay? And then the powers of a is descending, alright? Starting from n minus 1, n minus 2, n minus 3. And the powers of b, starting from b to the power of 0, they are increasing, okay? And in short, if you look at this formula, always remember this one. Combination of n taken r multiplied to a to the power of n minus r times b to the power of r. By the way, um, the a here is actually for the first term because sometimes it's not a. Sometimes it is 2x. Sometimes it has a power also. So the a there is the first term in the binomial. Remember that. And then the b, whatever that is, it is the second term in the binomial expansion. All right. Okay, so that is the binomial theorem. And then let's try to expand a plus b to the power of 5. Okay, now I advise actually my students, okay, if this is your first time knowing about this, if you're still unfamiliar with this, it is better for you to do the expansion vertically, okay, to find the terms in this expansion in a vertical manner. So let's illustrate that. So since you have, okay, let's start with the coefficients. Combination of 5 taken 0, our index is 5. So we start with r is equal to 0 and then do it vertically until you reach combination of 5 taken 5. All right. And then let's go to the first term. Our first term is a. So remember, the powers of a, the powers of the first term are descending or decreasing starting from 5. Okay? So if you're going to do this, you won't miss a term. Okay? Your terms will be complete because that's a common mistake. Sometimes uh, when they do expanding like this, there's a missing term. Okay? So take note, since the index is 5, then we expect how many terms? 6 terms. Okay? Now, what about the powers of the second term, which is b? And the powers will be increasing starting from 0. Always don't forget the b to the power of 0 or the 0th exponent. Alright? Okay, so that's it. And all we need to do is just to simplify, to write it nicely. Combination of 5 taken 0 is just 1, b to the power of 0 is just 1, so we are left with a to the power of 5. Alright? Okay, you can use your scientific calculator with this. Combination of 5 taken 1 is just 5. And then a to the power of 4 times b, okay, because it is customary that if the exponent is 1, we can just simply remove it, and then that's just b. Okay, combination of 5 taken 2 is 10a cubed b squared, and then take note that combination of 5 taken 2 is just the same with combination of 5 taken 3, because 3 is equal to 5 minus 2. Okay, then combination of 5 taken 4 is equal to 5a b to the power of 4, and then a to the power of 0 is 1. Combination of 5 taken 5 is just 1, therefore it's just b to the power of 5. And then of course you have to like write it horizontally, because our expansion is the sum of all of these terms. Okay, this expansion is the sum of all of these terms. So a to the power of 5 plus 5a to the power of 4b plus 10a cubed b squared plus 10a squared b cubed plus 5a to the b to the power of 4 plus b to the power of 5. So you have to write it in this manner, okay? So if you use the vertical way of doing it, do not just end your working, do not stop in something like this. So you have to write it this way as a sum of all of those terms. Okay, now let's go to the next example. Expand 2x minus y squared to the power of 4. So this is what I was talking about to you earlier. All right, wherein this cannot just be always a, or the second term to be always b. So sometimes sometimes it is something else. All right, to make it more complicated. But what you have to remember is the concept. Okay, the generalizations that we came up with from the Pascal's triangles video, and to the powers of the first term and second term. All right. Okay. And then take note also that our second term is not just y squared. Okay. Our second term is negative y squared. And our first term is 2x. Okay. Make sure that you identify that correctly. Otherwise, your long working would be uh, would be would become to a waste. All right. Okay, so let's start with the coefficients. So the index is 4, so we start with 4, combination of 4 taken 0, down to combination of 4 taken 4. Okay? All right, so how many terms do we have? 1, 2, 3, 4, 5. Because the index is 4, then we must have 5 terms. Okay, now let's go to the first term. The powers of the first term are descending or decreasing. So we start with the power of 4. All right, so that will be 2x. So make sure that it is inside a bracket, because the first term is not just x. The first term is 2x, which should be raised to the power of 4. Okay, don't forget that. And the second term is negative y squared. Again, it should be inside a bracket. All right, sometimes it is safer to do it like this, wherein you write everything like that, so that you won't get confused. All right, so this is how it should look like. Then simplifying will come in. Okay, this is what I said earlier, that you have to be good in the laws of indices. So all right, this is just 1. Combination of 4 taken 0 is just 1. So we are left with bracket 2x to the power of 4. When you simplify, when you remove the bracket, when you remove the parenthesis, it is just 16x to the power of 4. Okay, so here you obtain this because you applied the laws of exponent. Then this one is combination of 4 taken 1 is equal to 4. 2x to the power of 3 is 8x cubed, and then negative y squared to the power of 1 is negative y squared. Okay, correct. Let's go to the third term. Combination of 4 taken 2 is 6. Then 2x squared is 4x squared. Okay, common mistake is usually the index 2 is just applied to x. Okay, don't forget that it should also be applied to the numerical coefficient. The negative y squared square. You see here the negative, okay, assuming that there is a negative 1 there. Okay, so negative 1 square is negative 1 times negative 1, which will give us positive 1. and y square square is y to the power of 4. All right, so please do not be confused with this. All right, so there's so many algebraic skills that are involved in here. Next, combination of 4 taken 3 is 4, and then times 2x, negative y squared cube. Okay, so here it's negative 1 to the power of 3. So negative 1 times negative 1 times negative 1 gives you negative 1. That's why this is negative. And y to the power of 6. Remember that law we're in? 2 index 2 should be multiplied to 3. All right, next. Uh, this is 1, 2x to the power of 0 is 1, combination of 4 taken 4 is 1, the negative y squared to the power of 4 is positive y to the power of 8. Okay, so sometimes look at this because our terms should be in simplest form. Okay, so um, if there are things that we need to multiply, you have to multiply. If there are common factors that we need to cancel out, then we have to do the simplification. All right, so write the terms now. The expansion is the sum of those terms, and it will look like this. All right, like 4 times 8 times negative will becomes negative 32. And then 6 times 4 is 24. 4 times 2 times negative 1, that becomes negative 8x y to the power of 6, then plus y to the power of 8. Okay, so let's go to our last example. Expand x squared minus 3 over x to the power of 3. Okay, so there's a fraction, which is our second term. Do not be scared about that, okay? So because it would be best to write the fraction as 3x to the power of negative 1. We have a certain law of index. The 3 over x is just 3x to the power of negative 1. I think if you write it this way, it would be less confusing, okay? So let's write it that way. So x squared minus 3x to the power of negative 1 cubed. Okay, so again, let's start with the coefficients, starting from combination of 3 taken 0 down to combination of 3 taken 3. And the powers of the first term will be descending or decreasing, so we will have it like this, x squared to the power of 3 down to x squared to the power of 0. And the second term, which is negative 3x to the power of negative 1. So we will have the powers of that to be increasing, starting from 0 down to 3 or up to 3. All right. Okay, so this is now where our algebra will come in. Okay, the laws of indices. So let's simplify. Okay, so let's begin with the first one. Combination of 3 taken 0 is 1. This is just 1, so we will have x to the power of 6. Okay, next. Combination of 3 taken 1 is 3. X square is x to the power of 4. And then, since this is just to the power of 1, so this is negative 3 to the power of 1, x to the power of negative 1 to the power of 1. So you can also do it this way. Do not hurry up because it might, this will definitely help you not to be very confused. Combination of 3 taken 2 is 3, and x squared to the power of 1 is x squared, and distribute 2 inside, that's going to be negative 3 squared, and then x to the power of negative 1 squared. Okay, so let's go to the last term. So this is 1, this is also 1, then this will be negative 3 to the power of 3, x to the power of negative 1 to the power of 3. Okay, so now let's simplify this further. So let's go to the second term, 3x to the power of 4. This is negative 3, okay? And then x to the power of negative 1 to the power of 1 is x to the negative 1. All right, and then let's simplify this. Negative 3 squared is 9, which because it is negative 3 times negative 3, so that's positive 9. Then x to the power of negative 2. All right. And the last one is negative 3 cubed is negative 3 times negative 3 times negative 3, giving us negative 27. And then x to the power of negative 3. Okay, now notice that here in the second term, for example, let me just change the color. Okay, so I think let's make it yellow. All right, so here x to the power of 4 and x to the power of negative 1. So that can still be simplified using the law of index or the laws of indices. Okay, in the same manner that the third should also be simplified. So to ensure that your terms are simplified, one variable should only be seen once. Okay, if there are two or more, then apply the laws of indices to combine them. Okay, so let's move on. X to the power of 6, this one is 3 times negative 3 is negative 9. Then x to the power of 4 times x to the power of negative 1, use the product rule wherein you have to add the indices. So 4 plus negative 1 will give you 3. Then 3 times 9 is 27. Now, take a look at this. X squared times x to the power of negative 2. So when you add the indices, 2 plus negative 2, that gives you 0. So x to the power of 0 is 1. So that's why this is just simply 27. Then negative 27, x to the power of negative 3. You see, there's only one x here. So it appears only once. So that means it's already simplified. Okay? Therefore, this is our expanded form of this. Okay. All right. So hope that you learn again something from me, guys. Thank you so much for listening. And again, special credit to the Slides Carnival for the wonderful PowerPoint template. If you do have questions, if you got so confused, or if you have some questions that you want me to answer or to pay attention to, please email me at jdtoday2014 at gmail.com. All right, so I'll be willing to help you.